2 sessions. The first session will be delivered by KC Santosh from University of South Dakota, and the second session is from Tapobrata Lahari from IIIT Allahabad. And as you all know, we are on the last day of the faculty development program on potential research avenues in computer science and biology. So the last session will be the valedictory function. Hope the day goes well. Before starting today's program, I want to give you a message that we are sorry to say that today we lost our honorable treasurer of Malna Technical Education Society, Mr. R. Sheshagiri. In connection to that, I want all of us to observe 1 minute silence. Yeah, thank you all. We shall start the session. The introduction of our renowned resource person by Professor Margaret from CSE department.
Good morning all. It's my pleasure to introduce today's renowned resource person to August gathering. Professor KC Santosh, Chair and Associate Professor, Department of Computer Science, the University of South Dakota. Professor Santosh served School of Computing and IT, Taylor's University as a visiting associate professor for 1 year. Worked as a research fellow at the US National Library of Medicine, National Institute of Health. Postdoctoral research scientist at the Loria Research Center. And he has also served as a research scientist at the Indria Nancy Grand Research Center, France. And also worked as a graduate research scholar at the SSIT Thammasat University, Thailand. He demonstrated expertise in artificial intelligence, machine learning, pattern recognition, computer vision, image processing, data mining, and big data with various application domains such as healthcare informatics and medical imaging, document imaging, biometrics, forensics, speech analysis, and the Internet of Things. His research projects are funded by multiple agencies such as STCRGP, Department of Education, National Science Foundation, and the Asian Office of Aerospace Research and Development. He is a proud recipient of the President's Research Excellence Award, USD 2019, and an award from the US Department of Health and Human Services 2014. We are fortunate to have him in this session. Sir, welcome, sir, and you can take over the session, sir.
Good, thank you. Before I start, what am I going to do is, everybody's hearing me okay? How am I going?
Yes, sir.
How am I going to know that everybody's hearing me okay? Is there any thumbs up, this and that? No, I think it should be okay, right?
Yes, sir.
Audible is good.
Yeah, it's clearly audible, sir. And
Good.
also visible.
It's visible. It's visible. I used to say that. What am I doing? Then people say that you take your spake out. And yes,
Yes.
thank you. Thank you very much for the invitation. It's midnight, almost midnight here, but I accepted this one for a different reason. Probably we'll meet you in person at some point in the days to come. COVID-19 hits us hard. And when I got this invitation, what am I going to do? I don't know what the FDP is about. And I used to have a full form of FDP all the time from India. I had no idea what the FDP is about. And I came to know FDP is Faculty Development Program. And I was a bit aware about what should be done in the Faculty Development Program. And I come to know anything that you can talk. And let's talk something about what I've been doing so far. I'm going to make fun a little bit, but bear with me. It's going to be nice. I will be having a very nice ride. All right. It's not the roller coaster train. It's a very nice speedy train, but it's nice one. So people call me Santosh the other way around, but my name is Casey. You call me Casey. If you have any questions, you can interrupt me anytime. And today, let's have a very nice journey about healthcare, and I would touch and discuss more about COVID-19. And we are computer scientists. Who doesn't like AI? Everybody likes AI today. You go to Starbucks, you want to buy coffee, very nice standing there, and the lady's gonna ask you, tell you that, do you want AI flavor instead of caramel or chocolate? You say yes, give it. What is AI? AB is really really fancy and impressive terminology these days. Very nice term. Everybody wants it. Why not computer science? So we talk about AI. And don't forget that I've got the research labs founded in 2015. And if you want to follow me there. We got nice stuff, very nice stuff, all publications. This and that, they're going to be there that way. Oh man, this is too big for me. Let's make, is it okay if I make it small like this? That's too big. It's not nice. Okay. This is good. Do you think it's okay? Anybody?
Yes, sir. Yes.
You can put it in the slide mode, sir. Slideshow mode.
That is too big for me because the slides, I cannot do that one. Or let me try. I do this, and it's too big for me.
This looks good.
Yes.
This looks much better. Okay, so you tell me this looks better, so I follow you. You're good, I'm good. That's where am I. So today we talk about AI, we talk about data, we talk about prediction. Now we will be talking about a screening process. All right. You know me well. That was a very nice introduction, but don't forget that I don't talk about how many papers I publish, because talking about how many, it's basically showy, right? Kind of attitude. We don't want to do attitude stuff in here. So, KC's new programs in the state of South Dakota. This is a new program here. Again, AI is kind of old-fashioned a program or terms, but it's still a new program. It's in the state of South Dakota. We offer USD, University of South Dakota, is the only university offers states only artificial intelligence program. You basically want to follow these, but you know I don't want to force. But the good thing is, if you really want to collaborate with us, visiting scholar exchange or faculty exchange, or you want to send students to us, and I can take care of them by providing a scholarship. I'm okay to do that as long as kids are good, faculty and their expertise all is good. All right. Otherwise, who cares? This is me and my university. One of the buildings where I'm staying right now, because I'm in the campus, university campus. That's basically a summer here, this side. Really nice summer. We have old, really old building down here. And if you see kind of ball-shaped thing all the way up here, that's the sports center. Really nice. And if you see winter, this is winter, we are in the winter season, you got to snow all time. So kind of having polar bear life in here, right? So today's talk, when we discuss, it's all about me. It's not about my institution I'm affiliated with. So if you want to blame me, not to the institution because I can't carry my institution's impression. Let me talk a little bit about smart healthcare. Since 2015, I have been trying to make or develop a smart healthcare, and my target is to make it done by 2030. The reason is this, because it is very, very important and it is the must. When we talk about an event in math or a sickness for healthcare, right? Sickness is an event. So the guy, the candidate like me, peasants like me, you, we go to see a doctor. We happen to talk to many people like this in here. Do you see my, oh, what is this? Do you see my arrow pointer here, pointer? Somebody see us? Can anybody see my pointer? Let's not. So that's a
No, sir.
You see, no, you cannot see my pointer. Okay. So if you cannot see my pointer, then I have to be, it's kind of blind. So I don't see you don't see me, and then I'm going to talk. Oh my God, this is kind of challenge for a teacher in education this time. So the first one at the left top, oh my God, keep moving. Okay, so the family is going to go and talk to the doctor. That's what you see, iconic picture there. Meaning all these speech, all these talks, discussions, this should be stored. This should be stored because we have the right to ask data at some point. But they don't want. They have never stored those data. Second, they store other data, something like blood pressure or this or that. They come from probably from the chest, they come from brain, they come from whatever. They always get stored because the exports, medical exports, they like to get stored. They want to process, but they don't store the communication in the beginning. Probably the communication with the receptionist or the communications along the hallway with the technologist to go to doctor. Probably chest x-rays kind of stuff, CT scans, this and that, they store. And at the end, they also store handwritten documents or printed documents for a prescription. Right? We are computer scientists. We see problems like speech processing if they store our communication. We are, again, we are data scientists, data analysts, whatever we call. We do data analysis, signal processing, and pattern recognition because these are all signal processing, pattern recognition problems. We are so good at figuring out the problems because we make problems when we solve problems and we make money out of it. Then you got image processing, pattern recognition because these are images, meaning chest X-rays, this and that. Another one, description. That's a document analysis. Is it my noise or somebody? Okay, so what happened is at the end, the guy has one sickness, the primary sickness, probably let's talk about HIV positive, right? And then the experts taking all the data from beginning to end until starting from communication to doctor up to the prescription handwritten at the end. And you have so many problems. You do all these data analysis, processing and speech processing, and all these things. It's not me controlling this. I don't know who is controlling. Okay. So then you are going to do some machine learning stops in between, and then you got processes. You got really nice processing in there. Then finally you figure out the same sicknesses, which is HIV positive. I'm supposing that the visualization, the data, all these balls down here are really nice. Balls in the top of visualization, you happen to see those bubbles connecting each other. One is red, other one is kind of greenish, more yellowish, and then so on, orange and so on, right? It means the connection between these bubbles is basically two different data. They connect about the same event, meaning HIV positive. At the same time, you want to see the consistency. How am I going to talk, or how the doctor's talking to me? Because if I've got HIV positive, then I will talk in different way. If I don't have, then I will talk in different way. And all these signals and the data they collect from our body, they're going to be exactly in the same way. Oops, what is wrong? Exactly in the same way that the event is about. So we want to see consistency checking. All these bubbles are the data coming from different sources. So we want to see whether they talk about the same event. Consistency checking, data visualizations are really important in terms of funding and asking for money. It's about grant proposals to get money and do smart healthcare for us. And decision making, it should not be like what we have today. It should be like, I don't care about you, I care about fact, and this is what it is. Humans always do the following. Casey, don't worry, you have no, you will be fine. You got HIV positive, but you will be fine. Come on, man, you lying me. If I get HIV positive, I'll be nervous, I'll be frustrated, I'll do all these kind of things which I shouldn't do. I'll die. But the doctor said, Casey, don't worry, he's gonna pat me like I'm a dog, right? So what we need is machine learning, what we need is a smart healthcare, and also artificial intelligence driven tools. That makes a lot of sense. So what is important here is, until now, we basically don't do that much about this process in healthcare. And also communication, that's what I'm talking about. Can we integrate, and sometime I'll publish this paper in 2019, and I got the whole idea in at that time. So idea is to talk about the same event, either HIV positive or COVID-19, through all these data. So multimodal data is data are the real good sources of understanding a actual event. One data basically mislead the information. We need to have a smart healthcare. All the data that are required for the medical experts, they store, but they don't store our communication. We need hospitality. It's not just hospital. We need also hospitality. We want they talk to us nice. We also have the right to ask the data, and we got the data, we analyze this way. So by 2030, my aim is to build a smart healthcare, at least prototyping, for the world. We tried having a fund, we didn't get it, and we tried mostly $3 million last time, and we probably getting it very close to the threshold. Let's move on. While talking about all these data for one event, just one event, I have to have that many data. Then we should be worried about big data, right? So there is a fun part in computer science, and we always make people fool, mainly parents and the kids. We say, I'm teaching big data. The guy who has been teaching big data doesn't really understand what the big data is about. How big is big? Who's going to tell us? Anybody can talk? Do we allow anybody to talk? I don't know. How big is big? Anybody can talk. Please.
So the data which cannot be handled by a normal CPU.
Then if I have money, I'm the richest guy, and I give you, you're my student, I give you, let's say, what do you want to buy? I said, I give you $3,000 and 3K, 3 grants, and how about that? It's still a big data for you? There is people too, right? Not like a poor professor in South Asia. Does it make sense? Okay, somehow you catch me right. Here's the thing: we shouldn't make people fool. Back in the 80s, we used to use a 8085 microprocessor to teach people, and still we're teaching the same thing for assembly language and so on. For these processors, even one Excel sheet is a big deal. They can't process in time. Then we keep moving on. If I spend one grant, meaning $1,000, then I can buy a really nice computer, i7 or so, even more, dual core, right, quad core or so. So that in this case, basically, an Excel sheet or a couple of Excel sheets or thousands of Excel sheets is no big deal. We can really process fast. And like you said, if I've got real money, good money, and I give you everything you need, then then everything is easy, everything is going to be processed. And now we have an understanding of pair processing at the same time. But again, we need to worry about big data. Big data is real. It's not fake, but people make it buzzword. Reason they don't know how to describe it. Like one of us said, mentioned that data is too big and processor can't really process. We call big data. Big data for you, 5,000 image data is really big because the processor is too small to process the data. But for me, it's not because I've got the money. I already told that. But how about this? The same thing can be. We can have a real comparison with the donkey. You've got two donkeys. You've got a big one. I got a small donkey, and we provide two bags at the back of the donkey. One is 50 pounds. The other one is 100 pounds. 100 pounds can carry. The one who carries 100 pounds is a big one, big donkey. He's good. The one who is going to carry 50 pounds, he hardly can carry that one. So I give you one more pound, then he's not going to go. He's flat down. Right? So that's big data for a 50 pounds guy. The other one is still handling. So donkey is donkey. So there is no big data then. Family is donkey, right? It's small donkey and big donkey. So here's the thing. Big data in healthcare can be described as follows. There are many ways to describe. We can take time. I have a book and a research article ongoing. How big is big for medical imaging, especially for COVID-19? It's coming soon. Please, if you really want to follow me in LinkedIn, just follow me and take a look. How big is big? It's going to come out soon, very soon. So check it out here. How big is big? Look at this one. How many of us know that every time we give a birth, then the kids, they have to get registered in their hospital system? Everybody has to get registered. Everybody has to have their height, measurement, all possible measurements from head to toe. And at the same time, blood pressure, this and that. Nobody is going to be away from this. Nobody can avoid. And data is really complex. And these scales and units are different. And one tool is not going to work. Is if we have to consider millions, billions of people, like COVID-19 shocks everybody. Right? So too many people having the same problem, having the same data of different scales, measurements, units, sometimes numeric data, sometimes image data, sometimes text data, too much. Who's going to handle? Then it's a big problem. This is a problem for data scientists, image data scientists, or what we call a machine learning, AI. So this is big data, considering a big population or considering the whole world's population, where every kids, when we give birth, they have to be registered until they die. It means I create data every day. You create data every day, and they have to be stored. I don't know. We store those data depending on the government and the states we live on, but they all have to be stored. And while I'm talking about smart healthcare, smart healthcare should. And I said, how about speech? Come on, I like speech too. So if I store those data, then it's going to be more huge, and that's what we call a real big data, because one single man or women or any transgender people, one human can produce a really big data. Now, here's a point. The point is different data types and one data mining tool is not going to work. We'll talk about AI, pattern recognition, machine learning, and more. I asked many students, many scholars in early career, and even so big established so-called scientists, what are you doing? He said, I am doing artificial intelligence. Can you be more precise? He's going to say pattern recognition. Then can you try to be more precise? No, anomaly detection. He's going to say everything. By the way, it happens to you too, right? You have to say, I do the same thing. Just you don't have to speak to me right now, but just realize that you are going to do the same thing. When I was in France, I've got the boss, and boss wrote this paper. He said, don't tell mom I'm doing a document analysis. She believes I'm in the computer vision field. Enough is enough. That's fair enough. That's where I studied my PhD, and this is the paper my boss, my big boss, was. He wrote this paper some time ago. Basically, it's what it is. We make things complicated for no reason. We try to advocate AI in different wings, and we try to attract parents, but basically we mess up everything. We should be really worried and very cautious about using right term, the right domain. That's what we discuss. Like I said, if we really want to talk, you have to talk data mining, you have to talk information retrieval up to data science. What I'm going to say here is this: we are we happen to be so fancy. We like impressions, we like more fancy stuff, and we like more sexy stuff. And remember that all these people who happen to be, who used to be, let's say, who used to be a database engineers, who don't know nothing about more than a database management system, they became overnight data scientists after 2005, 2005, because we like sexy terms. We didn't do anything wrong, by the way, but we like sexy terms. Reason is the database engineers, how come they became data scientists? Come on, man. These days they say data scientist is not good, data analyst is good. Come on. This enough, right? Man, wake up. Nobody's going to do that because they like these terms. Think it's okay to have money. It's okay to have market that way. But again, we are academicians. We really have to think and use the right term, not like what the market has been using, not like what Elon Musk is using, not like what Facebook is doing, this, that. But we are academicians. Please careful about next generations, like our kids and so on. Let's talk about healthcare now. I just give you an idea about what AI, pattern recognition, this and that. It's kind of my experience about what I have learned from people and just trying to share. When we talk about pulmonary abnormalities, then probably you talk about lungs, right? You have both right and left lung sections, and they got a lot of problems, by the way. Bronchitis, asthma, emphysema, lung cancer, pneumonia, tuberculosis, again, so on and so on. And sometimes you probably need to know obesity is also a problem. That will cause lung abnormalities. Too many. Let's talk about what do you see here? Basically, you see a little bit of problem, but what is the problem? Is it asthma? Is it tuberculosis? Is it pneumonia? You don't know. Let me just go right away. This is asthma cases. Only medical experts know. We don't know. We see some problems there, right? We just see some problems. We're computer scientists. We're a big guy. How about this? This is pneumonia cases. Do you find any difference with asthma cases? Probably not. Again, we're computer scientists. We're big. All right, so try and see this and that, and then come to tuberculosis. Tell me which one is normal. I already give you samples. Which one is normal? Which one is not? Left, middle, right. Tell me which one is abnormal and which one is normal and which one is okay. Normal, abnormal, just do it. Somebody can tell? Left, one guy is okay to just tell. Somebody can do that? I just try to wake you up. Can anybody tell me one is not normal? Which one is not normal?
The right one.
The right is right one means right one is normal. Is that what you're saying?
Yes.
Which one is abnormal?
Seems to be the middle one.
How about the left one?
Not sure.
Left one is abnormal, right one is normal, and middle one is abnormal. But that's what basically, if you take a look close now, this is all about pattern analysis and machine intelligence problem, right? Pretty much clear. You've got a little bit higher enlargement here, but these are norms. They should be there. But this one is more kind of cloudy. Middle one is more cloudy. You don't really see the whole lung section. You need to see lobes, right? Lung section lobes or lung lobes. And then the left one, the leftmost one is kind of cloudy, and you don't really see the right clear lung section. So if you see all these things, it's all about pattern analysis, textures. It's all about texture. So like I said, don't tell your mom I'm doing document analysis because she knows that you're in the computer vision field. It is a computer vision problem, isn't that? So it's a texture analysis is a computer vision problem. It is all about feature extraction. If you do right feature extraction, you could do it. And I'm talking about tuberculosis, basically, right? The tuberculosis is one of the deadliest threats in the world. And when I was at National Institutes of Health, I was one of the core members, and we did that one. I was kind of big that time, really big, 230 pounds, big guy. Big guys should be always big. So that's me, and we set up this one in mostly South Africa and Kenya. And we don't want to talk about tuberculosis. I'm not going to educate you, but here's the deal. Deal is too many people got tuberculosis every year, and out of those tuberculosis, we still also have HIV positive. It's a threat. In top 10 countries, in China, India, China, Indonesia, who is going to read? Nobody. Let's remove. TB diagnosis is going to happen this way. Number one, you cough and people test in the laboratory settings, and you also have a skin test. You do the skin test, but this is frustrating because it is expensive, and you have to wait to the results, probably 2 weeks, 3 weeks, sometime a couple of days, but you need to pay extra money. It's frustrating and time consuming. What we've been trying is to facilitate the machine, AI-driven tool that can easily detect, oh, this lady has got tuberculosis, not others, right? That means we want to do TB screening, tuberculosis screening less than a second. How am I going to do the image then, right? If I want to do less than a second, then it's not about hospital settings, it's non-hospital settings. While I'm working with the government, I was a government scientist before I came to USD, US government, and we try to have this nice truck with the US aid and empath and so on. With this truck has got it is in Kenya. It was in Kenya that time, just to collect data, and this has got a very nice extra machine inside. You just get in there. We have a machine on the other side, which is basically a laptop or Mac Mini or so, and we get the data in iCloud. It's a cloud. It's just a cloud, and we process the data from National Library of Medicine, which is Washington DC. That's where we process the data for Kenya and Kenyan people. They get X-rayed that way in the village. Basically, this truck is basically driven from one village to the other village because people don't want to go to a hospital. Why they don't want to go to hospital? We have a big story, long story, but I don't want to tell you. But to take one data from here, they used to pay $10, and $10 has been used for other reason. Like I said, when we ask them to go for a data collection, meaning we need to have data to realize that AI-driven tools is going to go okay or not, then they don't want to do it because the reason is they're scared. First thing. The second thing is the government don't want to take the data away from from the citizens. All right. So what will happen? We give them $10, and $10 has been used for some different reason. Like I said, remember that. I will say something here. 13%. 13%. Somebody's talking. Is that? Sorry about that. 13% of the tuberculosis also having HIV positive. That means that $10 is going to go HIV positive to find mate, and they find mate and they increase HIV positive. Later, $10 has been used for grocery stores. Like I said, when you don't have hospital settings, you're going to receive these kind of images. These images are too raw, and they sometimes inclined and oriented in a different way, not upright. So many problems, and still the contrast is not good because in the truck it's not hospital settings. The problem is this: if it is not upright, then you basically cannot do things. So how difficult it is if I say it is not upright, how am I going to do it? Then the radiologist, they're going to tell you that you have to have the spinous process in the middle, this line, blue line, and you also have you have to detect clavicle heads, and the equidistance, the distance from one clavicle head to the spinous middle of the spinous process, and vice versa. They have to be equidistance. Oh man, how am I going to do that if the computer vision technique, when I detect clavicle heads and they are, let's say, 10 pixels away, deviated from what it should be, then I make wrong decision. That's not good. I ask them, how are you going to teach? Medical scientists also been taught by professors that they teach this way. They have the X-ray images on one side and they draw that way. Oh, it's all about ribs. It's all about ACE map, right? I understand that, not the other one. So I understand ACE maps because I see ribs, all these line drawings. That's pretty much good. what I see is if the clavicle head's got a problem, then it should be a ribs problem too. It's kind of hanger. If you have the code and one part of the hanger is let's say broken, and then you're going to be like that, right? So that means your whole orientation of the ribs is going to be a problem. Instead of detecting clavicle heads, I'd say in the rule is the criteria basically. The criteria is you should be having the same ribs orientation, global orientation from both sides. That's what it should be, like alpha 1 is equal to alpha 2. That's what it should be. And I realized this with the help of convolution, SMAP, and everything. And with the help of Gaussian coronals, really nice Gaussian coronals, and they do convolve with the SMAP. This is the area with which we want to talk. And because the lung section is our in region of interest, we apply coronals and we do convolution from 0 degree to 180 degree every 1 degree interval, and then we got this. Finally, we got a histogram like that. And if the X-ray is upright, you don't really see a problem in terms of alpha 1, alpha 2, no difference, no rotation. If there is a difference rotation, the difference is going to give you a chance to correct and make it upright. You do quality checking because it's all about non-hospital settings, and then you do see these abnormalities from left to right. And it's all about all these problems. We basically don't care about those problems because we're computer scientists, like I said, I mentioned over and over. And if you see how to understand the features, right, just get these lung segmentation done, which is fully automated. And we did that one in the library, basically in our research lab, fully automated. These red nice segmentations is all fully automated. And I understand something out of here. It's all about symmetric analysis, right? When we talk about symmetry analysis, you happen to see this nice maze at the left side. That is a very nice reflection of the Himalayan region. Basically, my childhood was there. I was born in Nepal, and that was my city. But it's been more than 20 years. Been not in Nepal. It's been a long time. So when I talk about this, the red line is the line of symmetry. It's pretty much hard to get things done. It's because this is a real computer vision problem. But if you go to the middle one is kind of very easy, because if you know one pixel, then you just vectorize it. Not like unlike the scene, the city scene, right? The Himalayan region. While the other one is line of symmetry. It's easy to find line of symmetry. It's because you need to just find the head, or tentacles, or antenna, whatever we call it, right? Or thorax, whatever we find. You just find it. Butterfly is easy to talk about symmetric analysis. Our problem is much easier. Why? Because you have two lung sections. This is right lung section, this is left. You just have to overlap them. How nice it is. You have the book. Let's say you have the book, and then book, you got one lung section here, the other one, just overlap it and see whether they are symmetric in nature. That's what we do, right? You just can fold them and see whether they are completely overlapped. If it is so, then why not? If there is a problem, if there is a problem, if there are some abnormalities, then this is not going to be overlapped 100%. This is more or less okay. And this one is good, by the way. I had a bit serious problem with the radiologist. What they said is, our body is not symmetric in nature, Casey. What are you doing? Come on, you crazy. I said, okay, let me do it, because machine learning will never lie. You radiologist can lie, but machine learning will never lie. If it's not symmetric, so what? But I will take close to symmetric value. That's what the machine learning is about. We will learn. If it is not symmetric, we will not. I don't care about that. So I keep doing under the hood, because he didn't like me to go through this process, because I basically run away from the clinical procedure, right? So doctors do like to have clinical procedures, even in the machine learning. That's what we started calling explainable machine learning, that even Oompa Loompa, nobody can explain what the deep learning is doing with in every nodes. Come on, that's stupid again, but it's good to have a market that way. So when we talk about these symmetric, there are many ways. Let's talk about shape. How am I going to get the shape? That's high level. Maybe ellipse, maybe this, maybe that. And probably these kind of boxes good. How about the high level features? Probably shape context, probably everybody knows about that. Meaning in every contour of the boundary, I happen to see log polar space, and I learn everything in terms of beans, which is in log polar space, which is this. And I happen to match both of them And blue is blue and red is red. You follow blue and red. And at the end, you've got the sub context cost, which is 0.12, because they're not maths. So you need to pay money. We pay $12 in there. $12745. Similarly, we do the other thing, which is texture representation, which is we call radon feature. Everybody knows these. And we got a very nice one. If you happen to see the downside, the downside of the CXR is giving you a more close approximation of overlap. But the upper one, the upper CXR, which is abnormal, basically is not giving you even a close approximation of the symmetry, because they're too different, very different. But this one downside is quite close. They're close, and that's not a real problem. So we understand things. And again, what I used to tell the healthcare experts that if you have really a problem, then you happen to see a lung with no really ribs. It is very similar to a snowstorm and hit the trees with no leaves. Very similar, right? So basically, you can count ribs. You don't know where the ribs are. Ribs are done. They are gone, or they're fractured, whatever it looks like that. It's because there's a problem. And you happen to see a spatial arrangement of these, spatial orientation of these gradients help based on the ASMAP. ASMAP is a good idea to represent. And we did that with different histogram. In this case, both sides, if you happen to see blue one is not really overlap with the red one. There's a difference. Same thing, we don't talk about textures. We really want to talk about textures because ASMAP is the derivative of the textures. We directly take textures from here. And we're partisan it because reason is we need to preserve the spatial property even though we take textures from every location. We'll try to see. We match everybody. For machine learning scientists, it is important to know the vector, each feature vector at the end should be really compact. Otherwise, it makes sense. When you go back here, what are you going to get? I got two long sections. I got this feature from here and this feature from there, and I just overlap them. I got a unique value. That is scalar, right? One value. I have go with 14 different features, and I have just 14 feature vectors values. That means my feature vector dimension is just 14. Do you think 14 feature vector dimension is possible? It is possible. And we got it done. We apply all these possible classifiers, Oompa Loompa classifiers, and we do k-fold cross validation. And you must be surprised that why not Casey is using deep learning on it. Come on, man, Casey is too conservative. He's conventional. I will tell you why. And then I will try these. We try different data sets. When it's Chinese data set, we got good results. And we got, don't forget that. Here's the guy who is using deep learning network. Who's the guy? 2017. Belite, Lobson Belite, okay, and Hong et al. 2016. They do deep learning, but they didn't do anything. But so we basically overcome them, right? Reason is we do export-based feature extraction. They believe in machine. Machine can distinguish, but not the problem. By the way, we want problem distinguished, not the test X-ray on the whole. That's why feature, a specific feature or export-based feature or clinical procedure-based features are more important in healthcare domain, not just the deep learning. And we do a good job, and here's our RC code. We don't want to talk about it, but forget. Now think about the following. So I'm going to spend quite 2 to 5 minutes here. So here's the thing. How good it will be if I train my machine in India and test somewhere in Italy. We don't do that. We never do that. And people think it's impossible. Reason? We never tried. And now I was thinking of, oh my God, think about the Wuhan, China, where we talk about COVID-19. All right, Wuhan, China, if they got that many data in the beginning, why not we develop a machine and send to Italy and get the things done? But we didn't do that. We just blame each other. So it's because of the following reason. The first is intensity variations because of different machines used. Second thing is about change demography, because you're big, I'm small, some people are small, some people big, and the people always blame the data, not the machine. Now I'm thinking, can we really train and do that? It's all about cross-population test and train model. We did really try, and we get very encouraging results in the very beginning, and we published that in Intrinsics in Medical Image. We did try again, and when we did try, let me try now. I can do exports-based feature extraction when I have very limited data, right? But if I've got data keeps increasing over time, do you think handcrafted features is going to work? Never work. That's why it's a time to say no to feature engineering. It will never work. It will work on the local data set, only small data set or the similar data set, not the diversified data set. So it's time to say no to feature engineering. So we tried this one. We published this paper in IEEE 33rd CBMS 2020, where I'm one of the general chairs. I did organize this conference in 2020 summer. We did a really good job, and we come up with the very encouraging results. We never get 100%. Nobody can do that. If I get 100% when things done, people don't want to see. We need to see problems after publications. That's why we keep moving on. Otherwise, it's done. We try so many different things in Samsonite family, this and that. We come up with some ideas and come really encouraging results. And the time comes at some point. Man, those test x-rays also got coins or jewelries or pacemakers or this and that. Are these abnormal stuff? Maybe not. And sometimes you get nipples. These are representing a nodule-like structure, and nodule is one of the primary indicators of tuberculosis. That's why most of the time machines are confused with circle-like objects like coin, nipple, jewelry, bottle cap, and ring, and so on. So what we need to do, we need to take them out. We did really try hard, and we did detect really good. If you see here, if you see there, we detect really good, and we take those foreign objects out, and we classify or we detect tuberculosis from chest X-ray eyes. Take a message. First thing, if you are drinking coffee, you don't want to use shovel because you have a shovel. It doesn't mean that you need to use shovel. If you are cleaning a driveway in the morning because it got heavy snowfall, then you want to try shovel, not this one. Meaning, if the problems are too complicated, the problem is diversified, and you have to deal with multiple data, then try use a sexy term, which is deep learning, which is we like. Otherwise, you don't want to use deep learning because it costs. You have to ask your supervisor to get more machine or a big machine. Spend more money. You don't want to do that. Optimization is always important, and that's even I'm rich. I'm not going to pay unless it's recorded. It's really required. So take a message is, even though we like sexy terms like deep learning, it is not always wise to use deep learning model for every simple problem. That's why I have two examples here. One is coffee, other one is this. Shovel is going to be used for snow cleaning, and spoon is going to be used for coffee because you need to take some more coffee or sugar. COVID-19, probably 10 minutes. I really want to talk about this one here thing. COVID-19 is we basically make people fun. We publish a lot of papers, and we've been trying to make people fooled by publications because COVID-19 says so. We have never done a good job. We never solved the society. We look after promotion. We look after, if you are the chair, you look for the dean. If you are the dean, you look for vice chancellor or provost or somebody else. Because we always make people fooled by publishing manipulative results, not the authentic one, and it doesn't really work. That's what COVID-19 says because we never do anything else. While talking about cross-population tools are really important because we can train the machine learning models in Wuhan, China during that 3 months, and we can easily deploy to Italy, India, and US itself. But we never did that because we are not believing those tools because we develop. We know how manipulative we are. Second thing, we never have machine. That machine can learn with me and with experts that we call active learning. I published the paper sometime in 2016. It's quite a new era in machine learning domain. We have to have a system that can learn like me and like my kid. That's what we call active learning over time. We also need to worry about not just test X-ray and I got 99%, I got a big paper. So what? You didn't really serve the society. You basically have to take care of multimodal and a little bit diversified data so that everybody understands you, everybody convinced you buy your product, and they will take it and make it commercialized. And we never happen to have these problems today of COVID-19. We never solved it. The COVID-19 is going to be solved by itself. First thing, COVID-19 is very hard. It's because of the spreading rate, not because of mortality rate, not because of death rate. It is because of the spreading rate. Lung cancer is killing more people than COVID-19 in a year. But lung cancer spreading rate is way low. Well, COVID-19 is basically sucks everybody. So important, WHO never provided a clear and right mathematical theory behind how they compute mortality and recovery rates, because they did wrong. And we published that paper some time ago in a Springer Nature, and it's in there probably last year, 2-3 months ago. It took time, but we revisited and we said their mortality rate computation and recovery rate computation is wrong. What did they say is this, basically, this is their mortality rate, we are here, right? They say that the mortality rate is this. Basically, no, mortality rate is really high. But if we end up with we get rid of this COVID-19, we will reach the end. That's why we don't see their problem. We get to intersect, we get to touch each other at the end. That's why we don't see the problem. But the problems are they did not have a right mathematical model. We had a talk and we discussed and they agreed on our mathematical model. I don't know they will take it because we are so happy with each other and we don't do that. Second thing, cross-population break, active learning. Like I said, it's very important. I published this one some time ago. It's probably the very, very popular paper in COVID-19 era. And this is really good. The other one is, here's the thing. If you want to take over time data, you need to worry about active learning. You need to worry about deep learning stuff because we got diversified data and so on. We make a final decision based on many different data, not just one data. That is important. I published this paper some time ago. And I gave an example of CT scan, cyst X-ray because they could be providing you a similar manifestation about the problem. Then why not use both? Yes, good. Then we tried in Sepsinate a model that's for COVID-19 detection. We tried this. Nobody understands this. I don't understand this one too. But so a little bit, and we got this really nice compact architecture. And we published this one some time ago for all the cyst X-rays. We tried to make COVID-19 distinction from pneumonia, tuberculosis, and healthy ones. And we did pretty much a good job. Some results we got here. If you happen to see D3 is getting 100%. I really don't like these results because 100% is almost impossible. Reason is it's probably the data set's too low, or probably data sets are biased, or we need to have more data. We always blame data, by the way, because we're good. We are so good, we blame data. We are bad. And here's the ROC curve. ROC curve is good for medical scientists. And here's the thing. So some time ago in April in 2020, people started doing COVID-19 with 25 minutes data, then 2068, then 50 and 50, and then 162. That's our data. Then we just compare each other. Then we never figure out how big is Big Bay, by the way. How big is big in amazing tools for COVID-19. I have the paper almost ready. It's going to come out, and you probably want to read that one because we always try to blame the data. We basically don't do right things because we want to have a promotion. We want to say, I published this. That's not good because we don't really serve the society. Let's not talk about this. We do. Oh, by the way, we do two different image data again in my research lab, and we use that one. We provide both things down here, CT and CXR, CT scan, CXR. We have the results, and results are really good, encouraging because we, like I said, CT scans and chest X-rays can provide you with similar manifestations of problems about particular event. Good, very good. I'm going to show you something here. I don't know how the video is. This is all about COVID-19. So because time is running out, this is amazing. Let me stop here. Oh, this is the one, and let me move on. I can give you one more video. These are funny stuff, but you may not like. There we go. This is fun, and I will take one more video. Let's start from here. This is much more faster. Figure out right path in no time. That's cool stuff. So too many things going on. What I'm doing these days, too many things going on, mostly healthcare and other things, COVID-19 and lung cancer. I'm doing more lung cancer stuff these days. And here is a take-home message from me, by the way. Whatever we talk is basically Oompa Loompa. This is a way to live life, by the way. The thing is you need to compete is your health. If you stay right, you always can compete with anybody else. And don't compete with your cousin, with your colleagues and the department people. Otherwise, it's not going to be FDP, the Faculty Development Program. It is all about you. If you are staying right in terms of health, then you always be right. If you want to look after me in terms of teaching, research, and other collaborations, if you have kids and students to be sent to USD for study, that's always welcome. I do run almost 10 miles almost every day before I come to teach. And here's my boy. This is my son. You probably want to see more stuff here. These two kids, mine. Thank you very much. If you have any questions, let's go.
Hello, sir.
Yes, please.
I have two basic questions, actually, very basics. I want to know how to decide about the feature selection in medical imaging research work, especially in medical imaging. Selection of features.
All right, so.
Yes, sir. The correct ones are stuck it now, sir.
Somebody's talking? Is it my time to respond to you? Is that right?
Yes, sir. Please.
Good. Good. So here is the deal. Deal is you don't decide. It's basically I usually give a talk in a different way. In healthcare, experts decide what to take.
Yes.
Medical experts decide what to take, not you.
Domain experts. Yeah.
Domain experts. Yes. Medical experts decide what to do, what to take, what to extract, not you. I see something different, but that's not going to be useful for them. If we don't follow clinical procedure, at least for image data, that means your system can have 100% or 99% results, but it's not convincing because you're not explainable. And they do like to see clinical procedure. Tell me, Casey, what do you do after this? Where is this image? Where is this object? This is the region of interest. I want to have this one at then so that I can talk to patient. Right?
Okay.
If you don't decide in a way they like, why do you build this? Right? Why do you make this?
Yes.
Just to make a paper? Probably that's a good idea because they need promotion. But we don't serve the society. It's because of that.
Yes.
We are obliged by a number of papers. I've got 300 plus papers. What the hell is going on, by the way? I don't really understand. Somebody says I have 50 plus. He doesn't know how many he's published by. So I feel like I'm really angry with those people who publish, but it's not about that. You need to publish ideas. You really need to. But for feature extraction, you basically want to see what they want, the medical experts want. They let them decide what features you want to extract and build exactly in the same way. So it's going to be explainable. And they take it. Otherwise, we build machine tool or whatever only for our promotion, only for hanging on in the rack. No more than that. Make sense?
Yes, sir. Thank you. I have one more small question. Yeah. In one of your papers, you have mentioned that AI-driven tools are required to be implemented from the beginning of data collection in parallel with the experts in the field where active learning needs to be employed. Can you throw more light upon it, sir?
Oh my God, you catch it right. So I want to see your face, by the way. You catch it really right. I don't know how we see each other, but this is terrible. Good. Thank you. So you don't introduce us. Can you introduce me?
Sir, I'm Professor Bharti from JSS Science and Technology University, Mysore, sir.
Oh, you're from DS Guru side.
Yeah, sir. Yeah.
Tell him hi. So
hello, sir.
Here's the thing. You kept me so right. I was like too fast, but you catch me. Thank you very much. You were so serious. You catch me. I'm so happy. Let's do the deal. Deal is this. We know the data always coming into play over time. It's not the end of the era, right? We always get data. We keep blaming data is too small. 3,000 data too small. 10,000 data too small. Because that's how PhD should be produced.
And moreover, the deep architecture needs
exactly. And then we start thinking, okay, now 10,000 data I cannot visualize. He cannot, she cannot. Let's do deep learning, which is a big deal, which is okay. Then in every node of the deep layer of the deep learning, we don't know what things is going on because it is not explainable. Then buzzword starts to play in the big world, our world. Oh, now explainable machine. Who can do that? Can you do kidding all the time? Come on, you can't do this, right? So you know those things. So what I'm saying is, can we have a closed loop control system? This is realistic. I'm not saying any buzzword here. You have the data, they come over time. In 2016, active learning, we published paper in machine learning. I'm the associate editor in there. I don't really introduce like I published 500 papers. I'm really poor in that case. Meaning not poor, I don't want to advocate myself. We published a paper stating that if we have single data today and we have money to do it, we wait for 2 years. We're stupid to do that. We don't do that. We start looking at, okay, I got this data. I never see it. Now, machine is going to do that, right? I never see, put it here, one pocket. I got other data. Oh, here's the data. I didn't see it, put it here. And I got, oh, I see this one the other day. Let's put it together. That's what active learning is.
Okay.
The machine will decide. No, we know similarity measure. We know everything. And I got this one. I have never seen this one. Come on, let's put it here for a second, right? And I got this one. I mean, this resembles this one. Let's put a bit closer, but not really close, right? So we know all these things. That's why we don't need to wait for all annotations. That's why we have another paper, label few, annotated complete, meaning the automatic annotations it's possible. If automatic annotation is possible for big data, active learning is also possible. We can make mistakes for serious issues like COVID-19, but why the hell these Wuhan people don't understand, even though Alibaba was there, right? Even though Alibaba, like Oompa Loompa experts there and ruin the whole world, why not we have data over time learned by the machine and deployed right away? Why not we think that way? Because we are so selfish, seeing about our promotion. I'm going to be retired. I need to get it. Let's politics. Do some politics. Have paper. Call people. Get my paper published. I'm going to get your paper published. I'm the associate editor here. You do that job. That's the politics happen in academia. That's why I advocate every people. Can you please stop? Can you not? Do you really not seeing your next generation kids? Your kids. Can you do your heads up at some point when your kids come back from Stanford University? Because you know he's going to know you right away, or she's going to know you, or they're going to know you, right? That's why active learning with the help of experts. That's the Wuhan case. It was possible, but we never did it. Reason is we play games and make people fool by publication. That's why nobody convinced, even the commercial people. We have to wait for vaccines. We're not convinced with the vaccines, but we're more or less okay because medical doctors are way less than computer scientists. They don't read. We read. You know what I'm saying? I'll make fun of it. So anyway, thank you very much.
Okay.
Thank you.
Thank you, sir. Sir, I have a very small, one more question about this active learning. Can I go ahead?
Yes.
What's the role of this extrapolating the data then?
What is the role of?
Extrapolating. Extrapolating the data. Sir?
So in active learning, what is the role of extrapolating data?
Yes.
Do you have an example? I didn't get you. Sorry about that.
No, generally we extrapolate the data like or extend the version of the data available and go with AI tools for analysis and so on. But as you told now, like we wait it or we go with the similar data and then.
Oh yeah, so that's why we said closed loop control system. Experts will help whenever I make mistakes. I'm in machine. Experts will help. It's a closed loop system. It's not one way. We basically do one way. We always take the data. We have ground truths. Wait for data for 2 years. Have the ground truth ready, and we throw the system. What's the use? No use.
Correct.
We have the data never annotated because of the COVID-19 case. Put the data in. Have the experts. We have to take care of the society, our humans, our family members, and so on. And have the data. Let the doctors decide. And then we train from the first day. See, this is here, and the system is going to decide and check. The medical experts will tell us what is happening. We make the real cluster of non-healthy and healthy one. Severity level will be going there right away, and we can serve the whole computer vision community in no time. And also research into not also research industry, but also serving the society. I love these kind of things, and it is possible. People just don't do it. Reason is, like I said, we are the associate editors, guest editors for free. And we make our worlds ruined, seriously ruined, and we have no idea we're going to show our face to our kids.
Thank you, sir. Thank you very much, sir. Thank you.
Let's have more questions.
Yes.
Thank you very much.
Participants, you can ask question now.
Please go for it. You don't have to hesitate asking questions. It's free. It's really free. Nobody's asking.
Sir, I have one more question, if you allow me.
Did I do it? So let's have somebody raise the hand, and then we'll go back to you again.
Okay.
I didn't say no. Okay, don't take me.
Okay.
Did I do that? That was not right. Nobody's asking questions. Did I do that? That was not right. Too bad. Come on. Hesitation's killing people, by the way. We shouldn't get ruined by ourselves. We should change habit, asking questions. Any questions? Where is your name is fine too, because my name is always confusing people. Anybody? Let's have one more question from Mysore. Mysore, please.
Hello.
Yes, please.
Sir, do you suggest any particular tools for image processing, sir?
Too many problems we got, but I would suggest if you are an early career research scientist or an established, we don't really care about that. We have a habit of categorizing people, but if you are really looking for something that would help, I would suggest not to do character recognition, not to do this oompa loompa stuff, because the money is not there. Neither you solve the society. When I said so, the big people like big people in India will be angry with me, but document analysis don't make sense. I can eat my rice, I can eat my lunch, I can eat my bread without having document analysis done, right? So I would suggest the following. When you choose the topic that you're so proud of the topic, meaning this is so challenging, this is the threat, I need to get it done. I really want to have something and serve the society. I want to have one block in there. That's why I want you think of healthcare more than other Oompa Loompa topic for fun. Face recognition, mostly for fun than security. All right, video games, this and that. Document image analysis, they all do script identification because India is too big and I have got that many multi-script, come on, what? Right? We don't have money for that. And we'll be having a nice PhD, but no money because we do crap in terms of choosing topic. So I want to suggest medical imaging or healthcare or public healthcare. The reason is, since the day we born, our data is going to be stored. Our data should be analyzed. And there is no way that we can skip health insurance. There is no way that we can skip going to hospital. Meaning there is a big scope, a huge scope for AI, people on healthcare. Take one of the topics in imaging data or any numeric data for healthcare, maybe public healthcare, that's a good deal. Then the other Oompa Loompa topics take into account. That makes sense? Did I give you something good, or I'm talking about just about me? I don't know.
No, sir. Yes, sir.
Good, very good. Let's go back to University of Mysore until we get the other one. The previous question.
Sir, in your previous work, you said that multimodal CT scan and X-ray, was it of the same person?
Oh, good. So basically, I'm kind of more ample guy, right? More ambitious guy. If it is the same person, awesome, right? Good stuff. But it's pretty much hard to have the same person have 2 CT scans provided for research purpose. We are so bad at getting or giving or providing research data. The reason is, again, we want to make people fooled by publication. I have the data, I publish this, that. What happened is the following. We want to have a diversified data. So let's say your cancer and my cancer should behave in a similar way. I want to learn the region of interest, not the exact person, not the specific person. Do you see what I'm saying? Do you understand? If we get data from exact same person, that is awesome, but we will not have it. But if you have a CT scan and you have the same sickness that I do have, and I have a chest X-ray, let's say you have a cancer and I have a cancer, you have a chest X-ray, I have a CT scan. The manifestations from me talking about cancer, talking about exact same event is going to be more or less similar to yours. So our network or model is going to learn that particular manifestation talking about that event, regardless of where the source is and where the data come from, or they are the exact same data or different modalities. Do you understand? So I want to learn things from diversified data about exact same manifestation, talking about exact same event.
Thank you, sir.
Right?
Thank you.
All right. So I think everybody's kind of shy people. More shy? Shy is not going to work. Let's have a couple of questions and I will drop back to home.
Participants, do you have any questions?
This is all about faculty, not about students, right?
Okay, thank you. Today's session, it was really very interesting, and sir has started with smart healthcare system and how actually the AI is involved, he has told. And also he has interestingly explained his work, that is tuberculosis in Kenya, the case study, and the chest x-ray and how the symmetry analysis and also automated chest x-ray screening and feature extraction, edge representation, texture representation, all those things he has clearly explained, and it is really useful to us. And also, along with that, he also explained about mortality and recovery rates of COVID-19, and many of his papers related to COVID-19 he has explained, and it was really good and it was really useful for us. And also how actually the machine learning, pattern recognition, data science, deep learning, all these are involved, he has explained. So it is really a very interesting and very useful information for us. Thank you very much, sir.
Thank you very much. Can I ask you one question? Does anybody know in the audience? Does anybody in the audience know me before I was invited?
No, sir.
Nobody knows. Poor guy. I'm a poor guy.
No, we are thankful to Dr. Geeta Kiran for introducing you to this whole community over here.
I don't know who's talking. BK. I know who's talking. Anyway, so I was thinking one of us in the audience is going to know me, but it's good. It's kind of completely stranger team, and we got no time to see each other. But I'm really fascinated by the people, that number of people, and they enjoying the talk. I don't believe they enjoy the talk, but it's still good. Hopefully, we will see in the future if I get a chance to visit India.
Thank you, sir.
All right, so we will leave now.
1 second.
Yes, sir. Thank you.
Now it's a time for
Thank you
Professor
for the great
Geeta.
session, sir. And I'm always thankful for you for accepting the invitation and giving out a great session over here. I hope participants have enjoyed your session. Thank you, sir. Thank you. We'll meet again, sir.
Ma'am,
All
can we
right,
have
good.
group
Thank
pic-
you. The face-to-face meeting is really encouraging and more motivative than this one, because we can spend time here and there. But again, look, this is how it should go. We should move on. I accepted this invitation. By the way, very frankly speaking, I hate FDP. I don't spend time on this, but this invitation I cannot deny. I did not know Professor Geeta. Geeta, right? This is what it is.
Yeah.
And I have a very good friend from Mysore, DS Guru. We call Professor Guru, right? Everybody calls.
Yes.
Because of him, I cannot deny, but frankly speaking, honestly speaking, I'm not a bad guy, but I don't accept this kind of invitation. I'm not a bad guy though, okay? But it's a very good chance, a very good opportunity to meet Professor Geeta. Really nice, but I didn't expect that much really nice audience down here. We basically don't listen to people, and very hard to have that much audience. But again, I never said no, but I never accepted offers from anybody else because I had to speak like this. But it's good. I visited twice India. I hope that 2022 we're going to have a conference starting from 2016. DS Guru, Professor Guru was there. I invited twice him. I met him in 2018. A nice guy. He looks old, but he's a very nice guy, by the way. I make fun of him all the time, but he's seriously nice. I probably come to India probably in 2022. And let's see what's going to happen. Thank you very much.
Thank you, sir. Thank you very much.
Ma'am, can we have a group photo, ma'am? Sir, can we have a group photo?
Sure. Teja.
How can you do that? Look I can see everybody now. Come on, why not we do that the other time? Oh my God. I see everybody now. Come on, why don't we see each other all the time? Here we go. How many of us here? So how long we wait?
It's done with. They're done with.
Oh, good.
Okay.
Very good then. Okay, see you.
Thank you,
See you
guys.
somewhere next time in person. Thank you very much.
Thank you, Bharti madam.
I even don't know how to leave out, by the way. Come on, man. I'm not old, but I'm looking old looking guy. How am I going to leave? Where is the button? Here we go, I find. Okay, so anyway, the last comment is if you want to connect with me, go to LinkedIn and try connect with me so we can see each other. We can talk about research collaboration. Thank you.